Have you ever wondered how linear equations are formed? Why are there different forms of linear equations? What's the value of each form and how each form is used in math in the real world? Lines are everywhere in the world, from design to data analysis. How can we distinguish one line from another? Basically, giving each line a name. And that's when equation comes into play. If I ask you what's the difference between the green, red, and the blue line, you would tell me it's their depth. That means the first thing that define an equation is the depth. In another word, the slope. Slope is the rate of change, meaning for every step I'm going up, how many steps am I going forward? So from this point, I'm going to measure how many steps I'm going up and how many steps I'm going over. So I'm going up 1, 2, okay, so I'm going up 2 steps. And then I'm going over 1 step. So that means my slope is 2 over 1, which is the same thing as 2. There is another way of finding the slope by using points. So on this graph, let's choose 2 clear points that you could easily read. I'm going to choose this point, which is -3, -1. And then I'm going to choose this point, which is 0, 1. Now, as we talked before, slope is rise over run. So how can I know how far I am going up without counting? And how would I know how far I need to go over without counting the steps? All you have to do is subtract 1 from -1. So if you do 1 minus -1, you have a double negative here, so we'll make it positive. So 1 plus 1 would be 2. Basically, this is known as y2 minus y1. And as you can see, going up, counting how many steps you take 1, 2. So you're going up 2. So this is correct. Now, to know the distance between this point and that point, you're going to subtract 0 minus 3. Now, again, you have double negative here, makes it positive 3. This is also known as x2 minus x1. This is where the equation m equal y2 minus y1 over x2 minus x1 comes from, which is also known as your delta y over delta x, which is your change in y over your change in x. Now, there are 3 forms of linear equation. The first one is called point-slope form, which is y minus y1 equal m times x minus x1. The second one is slope-intercept form, which is y equal mx plus b. The third one is standard form, which is ax plus by equals c. Now I'm going to show you that just by knowing the slope equation, you can easily get all of these 3 forms. Remember that the slope equation is m equal change in y over change in x, which is y2 minus y1 over x2 minus x1. Before I talk about where each form comes from or how each form is created just by knowing the slope, I want to first go back to a point that I made earlier. I said that one of the things that define a line is its slope. Okay, so if you look at the red line and the blue line, you will notice that they have the same slope. So how are they different? Remember, an equation should be like a name that define one line. So how does the red different than the blue? And if you look closely, you will notice what's different is the y-intercept and the x-intercept. So the next thing that defines a line is not just the slope, but also the y-intercept. There's something else I want you to keep in mind. That if you got your slope by having 2 points, that means you already have your y-intercept. Because the points on the red line are different than the points on the blue line. They're never going to be the same points. So let's talk about how to get the point slope form. Remember how I just said that if you have 2 points, then that's automatically gives you the line. So let's say you have x1, y1, that's your first point, x2, y2, that's your second point. I'm going to write the slope equation, which is m equal to y2 minus y1 over x2 minus x1. Now to get the point slope form, all you have to do is multiply each side by x2 minus x1. This cancels out, and then you have x2 minus x1 times m equal y2 minus y1. This is your point slope form. Now let's talk about where the slope intercept form come from. Remember that slope is the change in y over the change in x. In other word, how does y get affected as x changes? Let's look at this line for example. What's the slope of this line? If you come right here, you will notice that you're going up 1, 2, so it's plus 2, and then over 1. So your slope is 2 over 1, which is 2. So your slope is equal to 2. So what will happen if my x is 1? Right there. So if I multiply my slope by 1, so 2 times 1 will equal to 2, right? You will notice that my y is 2. What if I multiply the slope by negative 1? So 2 times negative 1 will equal to negative 2. That's why your y is going to be equal to your slope times your x. There's something that is still missing. We know that slope-intercept form is y equal mx plus b. We know where the y equal mx came from, but where is the b coming from? If we look at both of those lines, we're going to realize that they have the same slope. They go up 2 and over 1. Up 2 and over 1. So we know that the slope is 2 for both of those lines. But they're not the same lines. If my x is 1, what is my y? I'm going to plug it in. Y equal 2 times 1. My y will equal to 2. So this is actually true. But when you come to this black line, if you say my x is -1, so y equal 2 times -1, the answer is going to be -2. But, well, this is not true. It's actually 0. And this is because the graph moved up 2 steps. If you add the y-intercept, which is +2, your answer is actually going to be 0, which is true. Let's look at this using a graphing calculator. This is my line where my y-intercept is 0. If I added 2 to the 2x plus 2, you will see that the graph is going to shift up 2 points. And if I subtracted 2 from the 2x, you're going to see that the graph is going to shift down 2 steps. That means when your b is positive, your graph shifts up, and when your b is negative, your graph shifts down. Let's move on to the standard form. To go from slope-intercept form to standard form, or to go from point-slope form to standard form, you're going to need numbers. That's why a lot of videos use examples. So the standard form equation is always known as ax plus by equals c, where a, b, and c are integers. So as you know, y equal mx plus b is our slope-intercept form. To go to standard form, you need your y and your x together on one side. So I'm going to subtract mx from both sides. What I got is -mx plus y equal b. Does that mean my b is the same as my c in the standard form? Or does that mean my slope, -m, is the value of a? No. That's why using an example is very important. So let's go ahead and use an example to show you why the standard form have the integers a, b, and c. So let's use our example, y equal 2 over 3x plus 5. We need to turn this into a standard form. I'm going to subtract 2 over 3x to both sides. Now, in this case, so far, it's true that 5 is my y-intercept. It's true that my a is the negative of my slope. However, I could change this and still have the standard form true. So let me show you how. I can change my -2 over 3 to be positive 2 over 3. And the way to do this is you divide -1 by the entire equation. Now, -5 is not my y-intercept, but the standard form is still true, where I have my x and I have my y on one side. Now, I could change the integer, which is -1, that is next to my y. And the way I could do that, I can multiply the 3 by the entire equation and get rid of that denominator 3. Now, with this new equation, I'm still holding my standard form,